This is Sai Nikhil from Engineering Physics third year. Today I am going to present a PPT on how to perform the force measurement experiment using the load cell. First we'll go through the aim of the experiment, then the setup and apparatus, then they'll go through the theory and the working of the load cell, then the procedure to perform this experiment, finally the observations and the conclusion. Our aim is to study the characteristics of the load cell using the force measurement trainer kit. The setup consists of a trainer kit, which consists of a load cell made up of four banded metal strain gauges with a cantilever base. There is an electronic circuitry, which consists of a Wheatstone bridge, an amplifier to amplify the signal, a zero adder and an adder with a digital voltmeter, and we have some weights of 100 grams, 200 grams and 500 grams. Coming to the theory part, load cells are the transducers that convert mechanical force or weight into an electrical signal. They are commonly used in industrial and scientific applications to measure force, weight, and pressure. Load cell can be categorized on the sensing technology such as strain gauges, hydraulic, and capacitive load cells. When a force is applied on load cell, tension and compression occurs at various places as shown here. If we attach strain gauges at those specific locations, we can configure them in a Wheatstone bridge circuit, and then we can measure the voltage difference across the bridge, which will be proportional to the applied weight. As we see here, when there is a weight applied, the load cell kind of deforms, which causes tension and compression in certain specific locations. And here in our load cell, these are the four strain gauges that we use in the specific locations. And when there is a load applied, these strain gauges can be stretched and compressed when they are placed at these locations, and then we get an electrical output from these strain gauges, which we can configure them and know the difference between the voltage difference in the Wheatstone bridge, and we can calibrate the into weight. Strain gauge load cell operates through changes in the electrical resistance. Systems using these types of load cells direct the force, measures force in a way that causes a deflection, tension or compression in the strain gauges. To accurately measure this resistance change, a strain gauge load cell employs a simple circuit known as Wheatstone bridge. Initially, the Wheatstone bridge is balanced, and each of the strain gauges is connected to the resistors in the Wheatstone bridge. When the load is placed on the load cell, the strain gauges connected to the load cell stretch and compress, which changes the resistance of the resistors in Wheatstone bridge, which makes the Wheatstone bridge unbalanced and causes a potential difference between these 2 points, which we can calculate, which we can measure, and then calibrate the weight or the load applied on the load cell. We'll now see how to perform the experiment. First, we have to connect the load cell to the trainer kit as shown. And then connect the display through jumper wires. And on the instrument, we can see that even though there is no load placed on the instrument, some readings is shown. So we need to make this zero using the zero adjust by rotating the zero adjust knob. Now it's zero. Now in order to calibrate this load cell, we use 1 kg weights. As we can see on the instrument, we can see 0.89 kgs display on the instrument. So in order to calibrate it, we can use the adder and make it to 1 kg. Now the instrument is calibrated. In order to take the observations, we can add 100 grams weights from 1 kg to 2 kgs and take 10 readings in increasing order. Then again perform the experiment in decreasing order from 2 kgs to 1 kg and take 10 readings. These are the readings when we perform the experiment in increasing or increasing load weight by 100 grams from 1 kg to 2 kg. Then we perform the same experiment from 2 kg to 1 kg by decreasing 100 grams. As we can observe that the DVM readings are not similar to the load applied. There is a little bit of error. And as we can also observe that the readings are not same for the same weights when perform the experiment in increasing order and decreasing order. This can be due to the hysteresis loss in the instrument. This is a graph plotted for our observations when the experiment is done by increasing the load weight, then decreasing the load weight. Coming to the conclusion and result part, the load cell shows a linear relationship as desired and can be used for measuring load with a good accuracy. We have seen in the before slide where we have plotted the graph for our observations, we have observed a very less amount of error, and the relationship between the load applied and the readings was almost linear, and we have observed a hysteresis loss of 0.02 kgs. We have to take some precautions while performing this experiment. We need to maintain a stable environment and the surface being undisturbed to avoid jitters in the measurement. We cannot overload this experiment as the load cell, as it increases the hysteresis error and possibly cause a permanent damage to the equipment. This was all about how to perform the force measurement experiment using the load cell. Thank you.